Hello everyone, I'm Will, and this is a little investigation into modeling soft root clusters for controlled harvesting. And the soft root we're working with is a strawberry cluster. You can see a nice one on the right there. We define a cluster as a collection of objects which require manipulation of non-goal objects to reach the goal object. So in this scenario, we've got a collection of, well, ripe fruits that we don't want to pick, unripe fruits, but also stems and leaves that all need pushing out of the way so that we can reach our target fruit. And in terms of the hardware that we're working with, they had a lot of problems developing systems that were able to identify the correct stem to snip. And so all the hardware works by grasping the right fruit and then moving up and snipping the correct stem. So that's the kind of thing we're working with. And intuitively, you start thinking about model predictive control for something like this. Ryan Hames from our group has worked on generating initial trajectories to identify goal target states for the cluster, and then also generate pushing actions using movement primitives. So then how can we, from a control point of view, ensure that the pushing actions have the desired effect, and how can we react when they don't? So that's the kind of model predictive idea behind this. And in this work, we're looking at just the trying to learn the cluster dynamics. In terms of environment representation, you could look into doing an object-based representation. So all harvesters have a camera which identifies the target fruit. So we could turn that image representation into a set of objects, but then you start thinking about, okay, well, that's going to be quite complex labeling given that there's such high rates of inclusion, and also which features do you want to include to your trained model or your training model. So then we sort of step back and we started to think about, okay, well, what about if we just tried video prediction? It doesn't need any labeling, and then the model can develop its own features. So that's the road we decided to go down with. And when you consider video prediction and robot pushing, you come to the convolutional dynamic neural advection model presented by Chelsea Finn, Ian Goodfellow, Sergey Levin. It's been adjusted slightly over the years, but basically it's the same concept. So can we use the CDNA prediction model for something like AS? We've got slightly different data. AS is 3D, theirs is 2D, so the model needs adjusting for that. And their objects are static, whereas AS are dynamic, although you can consider that their objects are more complex as well. So how's CDNA going to do with straw? So this is COVID times, so it's simulated data only. We collected a set of video pushing actions on clusters which were simple PD pendulums, PD controlled pendulums, 1 to 3 strawberries with variance in position and orientation to provide with a pretty complex data set. And the Cartesian pushing actions that we made were completely random. So this is an example of the kind of pushing action we did. Obviously, this is 4 strawberries, but we actually only collected with 3. It gives you a good idea of what's going on. So you can see the PD controllers working quite nicely there. So then applying CDNA to our problem. Chelsea Finn et al. Collected 150,000 samples for their data set, but obviously that's impractical for us, and we're looking at using very, very minimal data because obviously working with natural objects is quite expensive. So we collected 500 interactions between the robot and the strawberry. And to keep it as simple as possible, just to see the performance, we just collected with 1 single strawberry, and we can always move up if it works. In terms of adjustments to their model, we increased the size of our data to 128 by 128 instead of 64 by 64 for images. And we also tiled a 7-feature 3D task-based trajectory instead of a 5-feature 2D task-based trajectory. Very simple changes, but necessary for our problem. And in terms of performance, PSNL value is not exactly very useful for anyone. I don't think if that number was slightly different, I don't think we really see. CDNA uses several frames of context before it starts making predictions. So we provided 8 steps of context, and then we predicted for 8 steps. And in terms of a realistic view of what's going on, I think this GIF shows quite nicely from our test data about what's happening. So you can see a lot of noise included there, but also you can see that the mask of the object and the mask of the robot itself moving quite nicely and quite similar to the ground truth. So that's fantastic. And now we can push to a more So finally, then, where do we want to go with this work? Well, obviously, we want to improve the simulation complexity, introduce multi-stem joints, increase the variety of strawberries we have, and then integrate within the MPC and see if it all works. Kind of assuming that it won't, and then we'll have to introduce a set of new features, such as like tactile data or something, to improve the prediction models accuracy. But yeah, that's everything from me. Thank you.